Okay, welcome everyone to our talk, If, When and How, Strategies Towards Web-Based Tooling. We will do the talk together. I would like to introduce Maximilian, who will do the second part of the talk, and my name is Jonas. I will do the first part of the talk. We are both working for EclipseSource. We are a company supporting our customers in creating tools in various domains. And the question whether to go for a web-based solution is playing a key role in many projects. And that's why we have submitted this talk, because we want to share our experience on that topic. Quick disclaimer before we get started with the topic. EclipseCon is very much about technology and about technological details. So many talks really cover frameworks and solutions in detail. This talk is a little bit of an exception, and the reason or the background for that is that switching to a web-based tool or migrating existing tool to a web-based solution is not something that you will do overnight. It's not like introducing a new framework, I don't know, switching to a new Java version. It's really a major endeavor. It's a technology shift, and those decisions do not happen that often, but currently is the time where almost every project that we are participating in deals with this question. So we find it important to share the experience we have made with this question and share some insights. The other disclaimer, maybe also at the beginning of the talk, we cannot provide a definite answer for any project without looking at the details. So we want to share general best patterns, best practice, and a blueprint of a process which hopefully helps you in your project to do the right decision. And this decision covers the if, the when, and the how. While for the how, we describe concepts rather than concrete technologies. If you look at the program of this conference, you find a high number of technical talks which discuss several solutions how to create web-based tooling more in detail. Okay, before we get started, another thing, let's quickly define what we mean by web-based or cloud-based, because there are different meanings of that. So you could consider Electron to be web-based. What we are talking about is a tool which is deployed remotely in the cloud or on-premise and accessed via a browser. And the idea is that you just have a link and you can access your workspace and an IDE and start coding. So it's roughly what we consider to be web-based tools. There are several subtypes in hybrid solution. Most of the considerations we do today can be applied for those two, but that's the prototype we talk about. Okay, so I will talk about the if. That's basically the motivation. Should you actually consider a web-based solution? And then I will hand over to Maximilian, who will cover the when and the how. When we talk about the if, first thing we should consider what are typical motivations to go to web-based solution? What are the typical advantages of a web-based solution? I will go into detail about those benefits, but just in a nutshell, the two major things are you can use modern UI technology, HTML, CSS, rendered in the browser, much or more powerful than current desktop technologies, at least for SWT. And you can simplify your deployment. So ideally, you just have a link that you can click in your browser and you're ready to code. So those are the two major advantages in a nutshell of a web-based solution. Now, while this sounds great, we should also look at the disadvantages or challenges, so to say, when going to a web-based solution. And also, again, in a nutshell, the typical challenges we see with web-based technologies is there is quite some uncertainty about frameworks. What do we mean by that? If we look at the desktop world, there has been Eclipse now for 17 years, and it was a very obvious choice if you want to create your own tool. Now, if we look at the web area, it's not so easy to pick the frameworks, even not the platform. There are several IDE platforms out there, and especially if you look at the technologies like UI frameworks, there are a lot of those too, and they change frequently, so it's very volatile. So It's not as easy as on the desktop. You need to be sure that your solutions can be maintained midterm. So for example, if you look at Angular, they have new major versions every year, and then there's React, and now there's Vue.js. So how to deal with this? This is definitely a challenge. And even though we have a lot of talks at this conference and in general about web technology, the truth is that the ecosystem for web-based or for building web-based tooling is still much smaller than the one on the desktop. The desktop basically has 17 or even more years of heads up. So there are not that many frameworks and technologies out there compared to the desktop. And that leads actually to the fact that typically, it depends on the use case, but typically it's more expensive to implement something on a web-based stack. There are opposite cases too, but complex tools, it will be very likely much more expensive to do this on a web stack. And that, to summarize that leads to the first very important lesson that we learned, and I think that's very, very important. Before you switch anything to the web, you should be clear about the benefits and advantages you gain from that. You should not just switch to the web for the sake of doing it, or because it's interesting to do, or because it's cool. You must be sure about the benefits. And how can you define the benefits? That's or a necessary exercise for this is something that we don't like so much as technology people. And it's very simple. We should look at our use cases, the use cases of our tool, and evaluate the benefits of those use cases being available in the web. I'm not talking about tools as a whole. I'm really talking about use cases because in many scenarios it is beneficial or there are huge benefits for some use cases, while some other use cases of your tool chain you don't gain so much benefits. Typical example that we already have today is that most code review systems are already supported in the browser, while most developers still use desktop IDEs. So this is a typical case of a mixture, because for the code review use case, we gain so many benefits having it in the web. Now, the scheme is very simple. Look at the use cases that you need to support with your tool, evaluate the benefits, like how much do you gain, and of course look at the costs. How much would it cost to transfer that to the web? And those two things in combination allow you to identify the most beneficial use cases for a migration, what we call the low-hanging fruits, and we suggest to start with those, obviously. Now, how do you evaluate the use cases? So you need some criteria for that, and I would like to go into detail about that, because I think everybody can come up with this. I just wanted to mention this as a process. Now let's dive into the interesting part. What are typical use cases of a tool, and what are typical advantages and disadvantages? Now, the criteria for switching to a web-based solution are typically the non-functional requirements, not so much the functional requirements, because we typically want to support the same features in the web-based solution. There are more, but the most common non-functional requirements that benefit from a web solution are the installability, portability, performance and responsiveness, usability, and the costs. Not all of them are beneficial for the web-based solution. So I would like to walk through those requirements, and for all of them mention some scenarios in which a tool or use case benefits from a web-based solution. So those are the pro-web cases. Some examples which wouldn't benefit from a web-based solution, and from there derive the typical decision criteria. And finally, also mention some other mitigations where you could gain the benefits that you typically get with a web-based solution, even without going for a web-based solution. So let's start with installability. Quick definition: that's the ability to install a tool as fast as possible with the lowest number of steps. So ideally, in the web-based solution, you just open a link, maybe you need to log in, compared to installing something on the desktop with a lot of steps and a lot of download time. So obviously this is a huge benefit of web-based solution, and I think it's hard to argue that a desktop solution works better or has advantages in installability. Now let's look at use cases that actually benefit from installability. Because while it is always great to improve the installability, the benefits actually really then depend on the use case. So what are the pro web use cases or examples? A good example is a tutorial. So for example, the tutorials that we had today in the morning, there are 3 hours for this tutorial, and if people want to join hands-on, if they spend, let's say, half an hour on the installation, you lose a lot of time of that tutorial. While if they can just access a link, that's great. So it's a perfect use case for online tooling. Same would be true if you have an online academy where people complete small exercises. Again, you don't want them to install anything, you want to get them going as quick as possible. Another good use case is an evaluation version. So you want people to try out your tool, but they should get going as quick as possible. You want to show them very fast, okay, this is the tool, this is the benefits. By the way, we observe many companies which start with an evaluation or marketing version in the web first, because that's really an important use case to show potential users what the tool does. And you cannot expect those people to set up the tool for 20 minutes before they see something. Code review is a very, very common use case. It's mainly already supported in the web. Quick contributions. That means you have an open source project and you expect small contributions from a lot of people. So they don't code very long, but they just want to change a few lines of code. So those are typical cases. What they all have in common is that the expected time of usage for the tool is not very long, and compared to that, you don't want to have a long installation time. True for all those cases. Now, what are contra-web use cases? Exactly the opposite. Let's assume you have a small and steady development team, I don't know, 5 people continuously working on a project for 5 years. They don't really care about installability. They install the tool and that's it. And then they work with it for month and month, maybe update it sometimes. Of course, it's also beneficial for them to have a better installability, but it doesn't play such a big role. Other contra-web use case, if you are happy with the standard IDE, and there is actually not a lot to install, it's just something to unzip, typically also get huge benefits from improving that. So the key decision criteria when it comes to installability are obviously the complexity of installation, so how long does that take? The number of users. The more users you have, the more important installability is. And the expected period of usage. So how long are users expected to use your tool? The shorter, the more important installability is. What are alternative mitigations compared to a web-based solution? In many, many projects, it is possible to simplify the setup. That means make it easier to install the tool, the database, the runtime, or whatever. And if you would spend the money that you could spend on web-based tools on simplifying the setup, probably many, many projects would gain a lot in their installation process. And another solution could be, alternative solution could be to automate your setup, for example, with tools like Eclipse Oomph. Okay, let's switch to the next one, portability. Compared to installability, that's the ability to access the tool from any device at any time. When we talk about tool, we include the ability to have the same setup on any device, so you can seamlessly switch workspaces or set up from and pick it up from your colleague. Now, again, what are pro web use cases? Again, we have the tutorial case. If I prepare a tutorial for 100 people and I don't know which operating system and hardware they have, it's great if it just works on every machine. Again, read only in review. You are likely to review some code on your mobile device, probably not so likely that you really code anytime soon on your mobile phone. If you have external non-PC users, let's say you have a tool which is not so much targeted at writing code, but let's say at reviewing some diagrams or I don't know, something like that. So if people or the users of your tool are expected to use other devices than standard PCs, that could benefit from the web. Typical example could be the web-based or content management system like WordPress. And if you have a very complex and specific runtime setup, so if it's important for you that you can share the current setup with a colleague, not just by pushing the code, but also sharing the current setup, the database or whatever, this benefits a lot from portability. Contra web use cases are if you have a very unified default hardware and runtime, let's say you always run on Windows and everything is the same, you don't gain much. That's basically it. So portability is definitely a key advantage of web-based solution. So the decision criteria is, do you have the need for shareable runtimes, and are those specific? So can you not just recreate them from scratch? Of course, the expected number of types of end-user devices. So if you have different devices, you gain from a web-based solution. The types of end users, are they likely to use different types of devices? And finally, alternative mitigation. If it's about the runtime only, so if your runtime setup for your tooling is very complicated, you can also just visualize that, for example, with Docker containers or on a workspace server. You don't necessarily have to re-implement the tool based on that. And the other one, just to have mentioned that, if it's not a common case to look at another machine, something like remote desktop can cover seldom cases where you just want to look at the developer's machine to see what's going on there. Performance and responsiveness. This is a criteria which doesn't have a clear winner. The pro web use cases are arising from the fact that if the tool is deployed on a central server, it typically scales better because you can just scale up the server, especially if you have a virtual solution, so you can just add more power to that. Where this brings benefits is, for example, if you have very long compilation times, extensive code analysis, so jobs that can just run on the server, so they don't block the developer's machine. Contra web use cases. Some people might disagree, but things like 3D modeling, which really depend on the local hardware, typically are still pro desktop. There are 3D tools in the browser too, but that's currently not the main area of benefit, I would say. The key decision criteria are, if you have extreme requirements on low latency, meaning low latency between the UI and the underlying business logic, then a web-based solution might be difficult to get right. However, in our times, if you look at the code completion, for example, that's happening over the network, we're almost there. So it's really as fast as on the desktop. There are some cases where the internet connection really plays a role. And if you have high performance requirements to run long-running operation, that could give you a hint that a web-based solution provides benefits. Alternative migrations, again, you could only visualize performance-hungry operations. So if users frequently have to run a very long analysis, you could put only this analysis on the server. About the usability, here it really plays a role who you talk to. There are people who really see web-based solutions as much more usable, but you also find people who prefer a desktop solution which has perfect key integration and so on. So the scheme that we actually can observe here, if we build tools for web developers, they typically prefer a web-based tool because they're just used to the browser and all its cool features. And if we talk to desktop developers, they typically prefer the look and feel and usability of a desktop-based tool. So the key decision criteria are really the user type. If you have a lot of operating system and hardware interaction, desktop has an advantage. Alternative mitigations, and that's happening a lot at the moment, is to use web technologies but deploy them as a desktop technology, as for example done by Visual Studio Code and Eclipse Theia in Electron. Now, final criteria, the cost, and that leads over to the question when and how. So what are good use cases? Of course, if you have low cost to transform them, and that depends very much on how big the tool is and on the framework support which is already out there. So very good use cases in a nutshell are if you have slim code editors, because there are already tools out there supporting this well. Also, not to forget, if your existing tool creates a lot of maintenance cost, then you might be better off implementing something new. So this is this example of the existing tool based on COBOL 1.0, and you don't find developers and it creates a lot of costs. Contra web use case, if you have a full-blown UML tool, for example, it will cost you a lot of money, and not all the frameworks are perfectly there in the web yet. Now, decision criteria, which tools are there, which developers do you have in your team, what frameworks are already there, and how many of the existing features can be reused. And of course, how many users do you expect? The more money you can probably spend. As alternative solutions or as good mitigations, we suggest you to go for minimal viable products and go in an incremental approach, and Maximilian will go into detail about that procedure now. So, short summary of if. We think it is very important to get a good understanding of the benefits before you do something, because in any case, it's not happening overnight and it will create effort. So you need to be sure about the benefits and ideally have a perfect ratio between the benefits and the cost you need to spend on this. And now I switch over to the when and how.
Thank you. So as usual, if there's something that actually needs to get done, it is my turn. So let's take a look on the when. And the when is not really one particular point in time. The when is multiple points in time, and the first one that we need to look at is now. I think it is very important now to look at the benefits, if it's really something you should do, and when you're convinced that you should do it, at least at some point in time, it's very important to develop a strategy. I'm going to go into details on how to come up with that strategy, and also to come up with a time plan. Because for many of the decisions you need to take in the future, it's important to know what is a potential time frame for a migration for my tool. And then quite short term, you might also already want to consider the migration that will happen in the future for architectural decisions you take now for your existing tool, because those might heavily influence the cost of a migration in the future. And then midterm, you want to go one step further and really prepare your architecture for a migration, because there's things you can do in your existing tool that will make it much simpler to do a migration later on. And then, of course, midterm, you will probably start to migrate some of the high-value use cases that are not that costly, that are these low-hanging fruits that Jonas mentioned earlier. Long-term, at some point, you want to migrate all the remaining use cases and then deprecate your desktop-based solution. What you need to do when you define your strategy is to plot those timeframes onto a timeline. That can be very rough, but I think it's important to understand what that is. Is it in 5, 7, 8, or 10 years that you want to get rid of your desktop-based tools? And those pictures on the right-hand side, I'm going to use them throughout the remaining slides to signal when to do what. Now, when we talk about the when, what are factors that you need to factor in for your decision? Obviously the benefits, right? The smaller the benefits, the less you're probably inclined to do it pretty soon. It also depends very much on your use case complexity or even the tool complexity at whole. If you have use cases that are not that complex and that can be covered with the existing feature support on the web, then maybe you're inclined to do it earlier. Then you might get into a competitive pressure situation where other competitors that have similar products are moving ahead and create some pressure for you to migrate. So that's also something to keep in mind. Same can happen on the technical side, the COBOL 1.0. I mean, there's variants of that. So if you have a technology that you know that is deprecated and that will go maybe into a bad maintenance situation soon, that might create some pressure for you to migrate. And then, last but not least, of course, your ability to actually invest in this migration and the team that can actually do the migration. Do they have the know-how? About the feature support, I plotted that graph, that very scientific graph, of course, on the right-hand side, but I try to show a little bit my expectation and to at least qualitatively show you where we are. So if I think about feature support for a typical modeling tool on the desktop, I think there is a very high feature coverage. So many of the features that you need are there, and it requires minimal customization and minimal glue code to get those up and running. What I expect for the future for the desktop-based, for this percentage of feature support is to decline slightly, because maybe some of the existing features are not maintained that well anymore, and also you might want to see some new features, but they never appear. Let's say maybe if Git would pop up in 10 years from now, would people really build a desktop-based client for it anymore? And if you look at the web-based side, I think currently the feature support is quite low if you look at a more complex tool. So you would have to do a lot of components yourself, you would have to do a lot of customizing, but it picks up really quickly. And at some point we will see the point where the feature support on a web-based platform will be better. Those graphs, of course, heavily depend on what kind of use cases you have, right? If you have only the use case of a textual programming editor where you want to support your specific programming language, then probably the red line is much higher than it appears here. So off to the how. Once you've decided you want to do it and you've decided for at least a rough point in time when you want to migrate, how do you do it? And there's 3 key learnings that we probably learned the hard way, and other people I guess too. And I find them quite important. And the first one is you need to migrate iteratively. Like it could quickly, you could come to the conclusion, well, now we need to redo the tool, let's just do the big rewrite, right? And then you start with that big rewrite and you have your legacy tool and the new tool, and you have to wait until the new tool is as powerful or almost as powerful as the old tool, and that takes forever, and basically you're spending double the money on maintenance and so on. So that can quickly spin out of control and can become a nightmare. So you should definitely migrate iteratively. I will go into detail about what I mean by that. Second important learning is migrate iteratively, and I cannot stress that enough, do it iteratively. So what do I mean by migrating iteratively? As I mentioned before, I don't mean rewrite everything and then switch the tools at some point. Because that can lead to a situation where you're stuck with a half-baked new tool, overloaded with the maintenance of an old tool, and you never get it done. And there is examples even in older history, like Netscape, for example. They did an entire rewrite of Netscape, and it killed the company. They tried to rewrite it, and it took much longer than it's supposed to take, and then the other browser manufacturers were able to catch up. And the responsible manager, his first name is Joel, I don't remember the last name, what he concluded from that is that they should have never done this big rewrite in the first place. Because there's a tendency to do that always, because there's always something wrong with your old legacy code base that could maybe be improved. And then all your developers will tell you, yeah, it's so bad, you need to fully rewrite it, and sooner or later the management is maybe also on board, and then you do it. But the code that you've written there usually is, maybe there's some bad technical decisions, but who says that you won't do them again? And maybe you might get rid of some of the bugs, but you will add other bugs to the new code base. Furthermore, you have made a lot of investment into the existing code base. So if you find any means, and I will show you some means at least, to preserve that investment, that is really worthwhile. Also, I've seen that in development teams, you need to onboard your development team. And it is very strange when you have a legacy team, and some people are in that team, and then you have the team that builds the new product. That creates tension between the two teams usually. Also, onboarding your customers is important. Not all customers will find it super great that you move your tool there now. So gradually onboarding them with an iterative approach is great. And finally, often it's not about building exactly the same tool that you had before just with web technology. This technology opens up different opportunities. Suddenly you only have a URL to reach that, and maybe that changes the requirements. And that is something you can only learn when you do it iteratively. Now, I've said all that about doing it iteratively, but what if you start with the low-hanging fruits, and then later on you discover, hey, okay, this complicated use case, it's not feasible, it doesn't work. So before you start doing it, and that's also something that I consider part of creating a strategy for migration, you need to build a proof of concept that you can actually achieve this product, that it can actually be done. It's also a good learning experience for the team, and it's about showing the weaknesses of the target platform. It will give you a more realistic time plan because you identify problems in creating this new tool, and it's something that should be done upfront. And it's only a proof of concept and only for the key feature. It's not a polished product, but I think to create a really feasible strategy, it's unavoidable. Now to the methods to actually support iterative migration. I will just quickly step through this set of methods that we found useful. It's surely not a complete set, but it's some methods that we use along the way. One of the things that you can do quite short term, if you develop a new feature and you discover that this feature maybe is even easier to do based on web technology. So an example that I like is maybe you know the D3 visualization library in JavaScript. It does awesome visualizations, and I don't know how to do them with Java. So when you have those kinds of use cases, sometimes it can be useful to just develop it with web-based technology and then plug it into your desktop-based tool with a browser widget. Right? There is, of course, some risks. If you have interaction like selection, drag and drop, you need to integrate that. But that can even lead to a new feature that you develop that is already web-based and that doesn't really cost you any additional money. Single sourcing. So the idea here is you want to share the code base between the desktop and the web variant so that you don't have the double maintenance. In my mind, a quite good example for that is the language server protocol. If you're not familiar with that, the idea is to extract the language smarts of a particular language into a server component, and then you can query this server component with an API, and you can use it in a desktop variant and in a web variant, and suddenly you have the same code base and you don't need to double maintain it. Declarative artifacts, kind of related. You extract some of your code into an artifact, into a declarative artifact. A good example in my mind here is, for example, JSON forms. The idea here is that when you have a form-based UI, you define a model, how that UI looks like, and then all you need to implement is a renderer. You don't have to re-implement all the form-based editors that you ever had. Comes with the risk of maybe the expressiveness is not high enough and the refactoring costs, obviously. Then something that probably is in every good software engineering book, extract services. Extract your business logic into a service, potentially even a deployable service. For example, if you have a validation, maybe you want to extract that validation into a service, maybe you can deploy the service somewhere and then the desktop and the web variant can just share it. Then something that's important, when you actually build a web-based solution, Jonas mentioned the high risk and the high uncertainty in the web environment, so I find it quite important to try to build standalone components that are independent as much as possible from web frameworks to lower your technology risk. And of course, reuse. Also an evergreen. Good examples for me are all the CLI tools that are available. You can often integrate them quite simply, even in a web-based solution. Even if you lose some of the functionality or if it's not as usable, I find it really good to reuse those to get further with what you have. Of course, it will hamper your usability at some points. So with 27 seconds left, what are the key takeaways? First of all, you need to thoroughly evaluate your benefits so that you're really clear about why you want to do that, and if it really bears any benefits for you that you are willing to take the cost for. And then we would advise to migrate iteratively, applying some of the techniques that I've mentioned earlier, so that you always, I think I forgot to stress that previously, so that you always deploy a shippable product to the customer, even with your web-based version, because only then you can really collect that experience. Propose those different methods to actually do that, and of course, call to action. What do I recommend to do now to analyze your use case, to define if you actually want to do it and when, to define a strategy and a time plan, and to build a POC to make sure that this time plan and strategy actually makes sense. Thank you very much. Now, before I would take some questions, one final comment, I will just leave that slide on. If you're interested about technical details, how to build such solutions, this is an excellent place to be. This is a list of favorite talks that I find valuable towards that. Feel free to visit them. Is there any questions so far? So everything is clear now. Okay, thank you. You can reach us at our booth if you have any more questions, or just come up now. Thanks.